Hello everybody and welcome to your video for lesson 2.1.4, which is called How Can I Use It? It is about angles and triangles. So we previously went over all of our different attributes of different angles, all of our different characteristics, and now we are actually going to put that to play in our actual shapes. So in a triangle, we're going to use all those different definitions to come up with different attributes that triangles have. So in today's lesson, you will discover that angles in a triangle add up to 180 degrees. You will also practice finding angles in complex diagrams that use multiple relationships. So we're kind of putting everything together here that you guys have done through the last 3 sections. So when you guys come in, the very first thing you're going to do is you guys are going to jump right into 2-37, which is just another tiling problem. So if you go back to the tiling problems we did in the last sections, it's very similar to that. So you're just going to go through and answer those questions. And then 38, you're going to use the theorem that we're going to talk about here shortly to figure out what x is equal to. Then you are going to learn some qualities about special triangles, about an equilateral triangle, about different isosceles triangle, isosceles right, and then just a normal isosceles triangle. And then you guys have a little team reasoning challenge. So that's what Monday's class is going to look like. You're going to go through those 4 problems. I think it's probably going to be a pretty quick lesson for you guys. But let's go ahead and jump in. I actually want to show you guys the Desmos activity for the triangle angle sum theorem. So here is the Desmos activity for the triangle angle sum theorem. So if you look over here, you can see that our angle A is 38, our angle B is 81, and our angle C is 62. And what I'm going to do here is I'm going to move these around, and what I want you to do is I want you to watch this sum. So this is the sum of all of the angles together. So I'll first start with moving angle A around. So here it becomes obtuse. Now it's acute. I can move B around. It's getting smaller. It's getting bigger. And then I can move C around. I can make A a right triangle. So moving all of these around, I showed you different types of triangles, the right triangle, obtuse, acute triangles. And if you notice, the one thing that has not changed at all is the sum. The sum has stayed 180 the entire time, no matter what is going on. So that is what you guys are going to work with today. That is the triangle angle sum theorem, is that all of the angles in the triangle add up to 180. So that's that right here, and then right here. And then I also want to show you guys it right here. So you could actually sit here and do this with a bunch of different triangles. So if I asked you all to draw a different triangle on a piece of paper, and then I asked you to cut out the angles, the sides like right here, and then put them on a line, so all of the nice crisp edges go together, you would see that no matter what triangle you drew, no matter who drew it, all of your angles would still add up to be 180 right here. So it's kind of a cool theorem. No matter what is going on, no matter what happens, you're always going to get 180 degrees. Alrighty, so that's the main idea for this lesson, and there's not very many problems in this section, like in this lesson, so I'm not going to do any of the problems from the book. For the main part of the lesson, what we're going to do is I'm going to review some terminology, and then we're going to go do 2 of the homework problems, and then you'll have 3 of the homework problems for the exit ticket. So really quick, let's go ahead and review the vocabulary just one more time. I know you guys are probably sick and tired of hearing it, but the more that you hear it, the better you're going to remember it. So vertical angles. Remember, vertical angles are 2 opposite angles formed by 2 intersecting lines. So if you look here, C and G are vertical angles, F and D are vertical angles, H and N are vertical angles, and M and K are vertical angles. So those vertical angles always have an equal measure to them, okay? Then we go on to corresponding angles. So the corresponding angles lie in the same position but in different points of the intersection of the transversal. So remember, the transversal is the line that cuts 2 lines in half. Most of the time we want to be working with parallel. So if you look at these 3 images, these are not parallel. So just be aware of that as we're going through this. So M and D are corresponding angles, because if you were to slide M on top of D, they would be the same angle only if the lines are parallel. So for this one, those are corresponding angles, but they would not be the same measure. You can obviously tell that they're not the same measure because they're not parallel lines. So this only works for parallel lines. Don't ask me why they didn't make those parallel lines in the book. I don't know. It would make more sense, but whatever. And it even says here, corresponding angles are congruent when lines intersected by the transversal are parallel. So it states that, but it doesn't show that. Then we have alternate interior angles. Alternate means different sides of the transversal, and interior means in between the two lines. So again here, F and M are alternate interior angles, and they would be congruent if these two lines right here were parallel. But they're not, so we can't assume that. Alrighty, so they would be the same measure. They would be congruent. Alrighty, and then the last definition is same side interior angles. So same side, they're on the same side of the transversal. They're interior, they're in between our two parallel lines. And again, they would add up to 180 only if the lines are parallel. So all of these rules only apply if the lines are parallel. You can still call them same side interior. So like I could sit here and say G and M are still same side interior. But I could not say that I could not sit here and say that G plus M is equal to 180. You cannot say that for this guy because the lines aren't parallel. Alrighty, so that was just a quick refresher. You guys went through the weekend, so just refreshing your memory on those really quick before you guys come into class on Monday, so you guys can use all these different theorems for your problems that you're going to be working on. Alrighty, so I'm actually going to take you back to the book really quick. You guys are going to have question 241 on your exit ticket, so you're going to be finding all of the different angle measures. You're going to have 242 on your exit ticket, so you're convincing somebody that the lines are perpendicular. We're going to go over 43 and 44 just because they're quick and easy review problems. And then you are going to have 45 on your exit ticket. Alrighty, so let's jump in to 43 and 44. Alrighty, so 43 says the diagram below represents only half of the shape and has a graph, let me start. The graph below represents only half of a shape that has the graph of y equals 1 as the line of symmetry. Draw the complete shape on your paper and label the coordinates of the missing vertices. Alrighty. So the first thing we need to establish is what is y equals 1. So y equals 1 is going to be this line right here. So all that they're saying is this line or this image is reflected over that line. So if it is reflected over those lines, this point and this point is not going to move at all. They're not going to move. So I'm just going to extend my graph down here a little bit. And then all we're going to do is just reflect the only 2 points we can reflect over the line. So I'm working with this point. It's 1, 2 away from the line. So I'm going to go 1, 2 away from the line. And this is also 2 points away. So I'm going to go 1, 2 right here. So that would be the completed shape. And it wants to know the vertices, the vertexes for those. So this point right here is going to be 3 and -1. So we'll call that one A. And then B is 7, -1. So that's all they're asking for right there. That's just reflecting over a line that they asked, and that is it. Alrighty. I have no idea what that name is. Janine? I don't know. Janine? Janine? We'll go with that. Measured the sides of a rectangle and found that the sides were 12 inches and 24 inches. Howard measured the same rectangle and found that the sides were 1 foot and 2 feet. When their math teacher asked them for the area, Janine said 288 and Howard said 2. Why did they get two different numbers for the area of the same rectangle? All right. Hopefully you are sitting there saying, why is this even a question in our textbooks? Hopefully, fingers crossed. But it is, and I just want to make sure that we understand what's going on and that we're going through all of the review problems, because there is a sequence behind all the review problems. So you're starting to look into area and perimeter here, so that's going to come up later down the road. So we just want to make sure that we're brushing up on our skills and we know what's going on here. So obviously there's 12 inches in a foot, which means that there are 24 inches in 2 feet. So all that they are doing is they are using two different units. One of them is using inches and one of them is using feet. So it's still the same thing, still the same rectangle, but one student's using inches while the other student's using feet. That's it. Nothing more to it than that. So it's a kind of a silly question to ask, but we'll still go over it just in case. So just the big idea behind this guy is that you're making sure you know what units you need to be in. If they ask you for the area in feet, but they give you inches, you're just being cautious of that because they will do that on the test at the end of the year. So I know that this video is kind of short, but I think that this lesson is going to go pretty quickly. So just remember the main idea here, that all of the angles in a triangle are going to add up to be 180 degrees. So that's the big picture for 2.1.4. So that's all I have for you guys. I hope you guys have a great weekend, and I will see you guys in class on Monday.